Okay, Bismillah Rahman Rahim. Welcome to the spring semester of MPhil and MS program of Kartaba University. My name is Fazal Rahman. I'll be teaching you advanced quantum mechanics. It is not really advanced. For you it may be advanced because you are not used to apply your knowledge to solve the problem. So basically it will be the old course which you have studied in your BS or MSc program, but my emphasis will be on problem solving. Well, quantum mechanics, you know, in physics you have studied mechanics, you have studied classical mechanics, and now you are studying quantum mechanics. Now you know that maybe 3,000-4,000 years before, physics was not in its present shape. At that time, people were only familiar with heavenly bodies, and they tried to look at those and try to understand their motion and the state of rest. At that time, the name of this subject was natural philosophy. Later on, this natural philosophy, it was divided among different sciences, and one is, which is very important, it is physics. So physics deals with the energy, with the study of matter and energy and their interconversion. This is very simple definition of that. Then within physics we have various branches, and you are familiar, okay, there is a mechanics, there is heat and thermodynamics, there is waves and oscillation, there is modern physics, etc., etc., nuclear physics, solid state physics, quantum mechanics. Now, why all these subjects? The thing is, in physics you come across with thermal problems, so you have to study heat and thermodynamics. You come across with the motion of bodies, you have to study mechanics. So what mechanics is? It is the mechanism of the bodies, that how they work. Okay? Now that mechanics is known as classical mechanics, because this mechanics was perfectly okay before the start of 20th century, because at that time the microscopic world of material was not known, and people knew only heavenly size object, big objects, macroscopic object, and in order to describe their motion they needed mechanics, and that mechanics is still used there. Then, you know, this subatomic world was, you know, discovered, molecules, atoms, etc., etc. In order to describe them, you cannot use each individual particle separated from other one at microscopic level, and therefore for that purpose you have to have collective effect, and hence you study the statistical mechanics. Okay, the statistical techniques which are used to study the mechanics of the objects, such as collection of large number of molecules of a gas, that is statistical mechanics. Then still there are other properties which have to be described at subatomic level and atomic level, and there was a need of new mechanics, and that is known as quantum mechanics, which is a more general mechanics. Now, historically, I am going to show you a page in the photograph. Look at that. Look at that page. There is a list given. There is a list given, and look at the list. Okay? It says discovery of electron. That was in 1897. That is how electrons were discovered, and that was discovered by J.J. Thomson. Okay? He measured E by M ratio of the electrons. Then was black body radiation, which was discovered by Max Planck in year 1900. Year 1900. Then photoelectric effect and its explanation, it was by Einstein in 1905. And let me mention here that photoelectric effect was already demonstrated practically in 1887 somewhere. Einstein only gave its theoretical explanation because old physics was unable to explain it. Similarly, the spectrum of black body radiation could not be explained with the help of old physics, and Max Planck introduced black body radiation law, which explained that. Then there was hydrogen atom theory, which was proposed by Bohr in 1913, and it is based on three postulates. First postulate says that electrons move in circular orbit around the nucleus, but they cannot move in any circular orbit. The second postulate says that they only move in selected orbits, the quantized orbit, and this was a departure from the old theory where there was a concept of continuity, whereas here there is concept of discreteness. Then in 1914, it is in fact the confirmation of this Bohr postulates and his theory, the discrete energy levels, by Frank Hurd's experiment. Then in 1922, Compton effect. In Compton effect, he used the particle aspect of electron, and he said that if you have electron which is moving with energy E is equal to h nu, then colliding with stationary electron, it loses some of its energy and it goes with smaller energy h nu dash. That is, its frequency becomes smaller. Okay. Then there was exclusion principle in 1924, which says that in a given quantum state, no two particles can have the same quantum numbers. Then there was matter waves, 1925, that was de Broglie. Then wave function was there in 1926, uncertainty principle 1927, experimental verification of electron waves 1927 by Davison and Germer experiment, wave function in 1926, Max Born. Okay, and I forgot one thing, it was discovery of nucleus in 1911 by Rutherford. Now all these things you can study very quickly, and you have studied already in chapter 1st of this book, which I'll be using it here. That is, the name of the book is Quantum Mechanics, Concepts and Application second edition is with me. Maybe you have Second edition is with me, but you can have a third edition if it is available in the market. The author name is Noureddin Sethi. Okay, and in chapter 1, which starts at page number 1, there is a historical note which I have already displayed to you. So that is briefly explained there, and then every concept in there, that is particle aspects of radiation, wave aspect of particle, all that experiments, they are explained there. और उसमें photoelectric effect, Compton effect, Bohr theory, they are given in detail. So my first advice is go through all these articles which I have mentioned in the list in showing you the photograph. Book is that one, and you will be studying the first chapter first, and then I'll give you the assignment. Now before that, my advice to all of you is that I want your number 1 name, that is the format. Number 2, the university number, such as 17,000, such as 17 something like that, 5 figure. Okay, that is the university number. Number 3 is your mobile number, that you will provide me on my WhatsApp. Provide on WhatsApp 0321 909 9482. That is my number. Provide me that so that I can have record of few people, and if I have some special thing, then I can contact you and can ask you if I have some important thing to convey my message. Okay, that is one thing. So दूसरी बात, when you have studied the material which I have asked you to do, then there are examples in the book, examples, they are solved example. Okay, 1.1, 1.2, 1.3, 1.5, 1.6, 1.7. Now this is on black body. That is photoelectric effect. This is Compton effect. This is Compton effect. This is de Broglie hypothesis. Uncertainty principle. This is Bohr theory. Of hydrogen atom. Okay, so material which you will be studying, then you can apply that material to solve these problems. Then these are solved problems. Study those as well, solved problems. One 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.9, 1.9, 1.10, 1.12, 1.16. These problems are also based on these materials. They are solved problems. Then there are exercises. They are not solved, unsolved. And these are 1.2, 1.3, 1.4, 1.10, 1.11, 1.14, 1.17, 1.30, 1.31, 1.33, 1.43 and 1.44. Now, you will study these for your own knowledge, and this you will solve them. Keep the record of that, which I will ask you to send it to me anytime which is convenient to me, okay? And that will be your first assignment, okay? Now, this is today's job, academic job. I am not going to do anything more today. One thing which I am going to explain. This course is of 100 marks, which are divided as follows. Home assignment, 20 marks. The assignment which I will give to you, from time to time you will solve it, you will submit it. At the end, whatever you get will find the total out of 20. Then you will have a midterm exam. After 7 lectures or so, or 8 lectures, you will have midterm exam. Whatever material is covered up to that time, that will be asked in that exam, and that is of 30 marks. Now the total marks are 50. And remaining 50 is for the final examination, which will be mostly based on the material which you will study after the midterm exam. But nevertheless, 1 or 2 questions will be from the old course, so that you just don't forget about that, okay? So that is just for how much in touch you are with the subject. Those 2 questions will be from the old course, that is from the material which you studied for the midterm exam, and remaining question will be based on the material which you study after the midterm exam. Now remember one more thing, there is a style of the paper. I'll describe it to you during the course of study. My exam is an open book exam. You can open book, you can discuss. You cannot, if it is sit-in exam, if the COVID-19 problem is over and it is the sit-in exam, then you can open the book, you can open the notes, but you cannot talk with people, you cannot contact your some friends or somebody on internet, you cannot take any help from the electronic devices. Of course, you can use calculators. But if it is the it is the COVID-19 problem still exists, then we have to go online examination, and I'll give you the question paper, and it is up to you how to solve it. But again, there is no compulsion to use, not to use book. Okay, you can use book. Okay, so it will be problem based. Thank you very much. We'll again meet next week. Thank you.